In the very beginning of questions, they give lots of information about the first figure. So we just focus here, and then they say AB prime is 40, and then BC and B prime D is 24, and also angle ABC is 80 degree and 80 degree. So this figure is symmetric. And then the question restrict the range of angle BCD. We are talking about angle BCD here. It's between 105 degree to 145 degree. We have defined the distance between AC. So they ask us to find the distance between AC but not in terms of something, which imply that it should be an exact value, a fixed value. So we just connect AC. And similar reason, we try to do the same on right hand side. Now we have two fixed triangle. If you focus here, angle BCD will not affect angle ABC. It's because SAS, the shape is already fixed. So angle BCD will only affect triangle ACD here. And then our target in part A is just focus on this triangle. So we draw this triangle. 40, 80 degree and 24. Our target is to find AC here. Together with our target, we have 1, 2, 3, 3 sides and also one angle. So we should apply cosine formula. Then we can include our target in one single formula. So we have c squared is equal to a squared plus b squared minus 2ab cosine angle c. We have 80 degree here, so c must represent its corresponding opposite sides x. So x squared is equal to a and b are 40 and 24. The angle here is 80 degree. So we can find out x easily. We just take square root on both sides. So we get 42.9, which means AC is equal to 42.9 cm. After that, we have to find angle ACB. ACB is talking about this angle. You can choose to use cosine formula because we have all three sides already, including this angle. Or you can use sine formula, which include a pair of angle and also a line, and also an angle and a line here. So if we consider sine formula to this angle, we have the corresponding opposite side and also 80 together with the answer in part A1. So we use sine formula. Sine angle ACB compared with its opposite side 40 is equal to sine 80 degree divided by its opposite side 42.925 something something. Then we just solve the equations. And then we use shift sign to remove the sign next to it. We get 66.6 degree, correct to three significant figures. Now come to the key part, is they ask you how the area of the paper cuts in this figure will change when the angle BCD change from the lower limit to the upper limit. So the key point is you have to realize the blue triangle here are fixed shape. So how does the area of the paper cuts vary is totally depends on the moving part triangle ACD. That's why our target is ACD. To set up some strategy, we have to find out the area of this triangle. While we already know AC is around 42.9, also the opposite sides. So to get the area of triangle, we have one formula, 1 over 2AB sine angle C. Here, we have AB, which means that two sides here. Then what is needed is the angle between it. So our target to understand how it's affected by this angle, we have to express angle CAD in terms of our input here. That's what we want to do. Now we go back to this figure. We already know that this part is 66.6 degree. Therefore, if we're just talking about this part, it is angle BCD, our target, minus 66.6 degree. And then for isosceles triangle, we know that then because two base angle are the same, so we can use 180 degree minus 2 times of angle ACD. Then we find our angle for the area now. So to write down the function of the area of the moving part, triangle ACD, then we start writing angle CAD now. So it's 313.2 degree and then minus 2 angle BCD here. And then therefore we can write down the area of triangle ACD is equal to 1 over 2, 42.9 square times sine 313.2 minus 2 times angle BCD. And then we have to express that this blue triangle here are fixed. So we let the area, you don't really need to calculate it, but of course you can. Just simply use 1 over 2 times 24 times 40 times sine 80 degree, but that's not our focus. So we just simply say that we let area of triangle ABC equal to A1. So area of triangle AB prime D also equal to A1, where A1 is a constant. To show that only the area of triangle ACD will affect the total area of the paper cards. And then finally, we find that this is fixed, this is fixed, so it totally depends on this part. And we have to know when BCD change from 105 to 145, how this angle is changed. When angle BCD is equal to 105 degree, our target is equal to 103 degree, correct to three significant figure. So, and then for the upper bound, when angle BCD is equal to 145 degree, then our target angle will become 23.2 degree. Correct to three significant figures. Now, that means our target angle will decrease from 103 degree to 23.2 degree. So angle CAD decreased from 103 to 23.2 degree. And then to analyze it in your graph, sine curve is like this, where the peak here is 90 degree. And then we from our starting point, which is larger than 90 degree, go back to 23 point something. So first, you find that the results, the sine ratio going up first, and then reach its maximum when angle CAD is equal to 90, and then go downward until the final point. That's how we analyze the change. The answer should be increase first and then decrease later. And you better describe, because they didn't write down the criteria very clearly, you better describe at which moment it's become maximum. That means when angle BCD is which angle it's become maximum. So to calculate the maximum, when angle CAD is equal to 90 degree, that means 313.2 degree minus 2 times of our input is equal to 90 degree. We get around 112 degree correct to three significance figure. So our answer is, the answer is the area increased when the input angle is between 105 degree to 112 degree. Afterward, the area decrease when the input angle is between 112 degree to 145 degree. One minor thing to beware is about the sign here. Equal case should not be included. Equal case is do not increase or decrease. And all the angles here are correct to three significance figures. In part B, angle BCD is fixed to 132 degree, and that is floated to become a figure 3B. And then they say we have to find the volume of the pyramid, so we need to get the height of this pyramid. It's easy to get the base area because the area is ACD, which is the changing triangle just now in a specific case. So our only mission is to find out H here. To find out this line, then of course we should focus on a plane including this line. One thing very important is this shape is symmetric, which means that the height, the projection of B to this plane must lie in the middle of this triangle, which means that the blue line, if we connect it, it will bisect CD. It is very important and also perpendicular to this foot. So to find out about this triangle, we have AB already, which is 40. And then we also need to find out from A to the midpoint. We just let the midpoint be M. To find out AM, I just need to draw the isosceles triangle from the top view. We know AC. AC is 42.9. Our part A answer. And then we have right angle. And also, we can find out angle ACD. It's because this triangle, we get 66.6 degree. So in this specific case, we just simply use 132 minus 66.6. We get 65.4 degree. To find out AM, we just simply use sine ratio. AM is equal to hypotenuse times sine 65.4 degree. Of course, you should use the true value stored in your calculator. We get AM, then we can get BM. Consider a shorter triangle. We have 24 here. But this time it's more difficult to find out angle BCM. So instead, I try to find out CM here. If I can find CM, then I can use Pythagoras theorem. So go back to this triangle. Our target is CM now. CM is 42.9 cosine 65.4 degree. So we get it back here. So this is equal to 17.862789 something. So to get this, we find BM is equal to square root 24 squared minus CM squared. We get 16.0287 something. And then we can find out, you may try to find out the height by using cosine formula to get this angle BAM, and then you use sine ratio, we get the height here. So I try to find out angle BAM now. So we get this angle is 23.36145985 something degree. And then we can get the height now by observing this right angle triangle. We can get the height is equal to sine ratio times the hypotenuse 40. 15.86 something cm. Finally, we just get the area of triangle ACD and also multiplied by the height divided by 3. Then by using calculator, we get 697.2247928 cm squared. Therefore, the volume is equal to 1 over 3, 697.2247928, and then times the height that we get 15.86 something something. Then we get 3690 correct to 3 significant figures.